In this video, we're going to take a closer look at a couple of specific types of Riemann sums that we can use to find areas under our curve. So I'm going to scroll down here just for a second to look at the graph. So the remainder of what we're doing here is we've got a function. We want to know the area under our curve from, say, A here at our beginning to B here. And one of our options is to chop this up into smaller intervals and then find rectangles underneath or kind of with our curve here and add up the areas of those rectangles, and that can help us approximate the area under our curve. And so when we're talking about, how do we make these heights of these rectangles, one of the choices that we have is to always use the left-hand side of our interval to make our height. So as again, a reminder of what we're doing is that we've got our interval from A to B, and we're going to chop it up like we said. So once we do that, we're going to sort of relabel A as x sub 0. That's going to be our start. And then we'll have x sub 1, x sub 2, x sub 3, 4, sub 5, and in this case, oops, I wrote 6 instead because that was on my mind. X sub 6, that's our end. We often write this as x sub n. And where do we have that right there? Yeah, so that we can talk about this in terms of different numbers of intervals. So what this is telling us is that we've got each of these subintervals. So a subinterval is just, sort of one of these intervals, any one of these intervals right here. So it could be A3 to A4. And we make a rectangle with each of these intervals. And when we're deciding here, okay, how are we going to make our height? If we're doing a left-hand sum, we're always going to use the left-hand side here to go up and make the height of our rectangle for every single one of those intervals. So how we end up writing that area or approximation to our area is that we do L with a subscript of n. So that's telling us how many rectangles that we made. And then we've got each of our areas. So we've got our height here. And this really is just x sub 0 plugged in into our function. And that gives us our y value. And that tells us how tall that rectangle is. And then delta x is our width. And that's going to be the same for all of our rectangles. And that shortens up into our summation notation that we start at I equaling 1 going to n. And we've got this x sub I minus 1 because when we start at I being 1, right, this is actually f of x sub 0, which is our left-hand side over here. And it ends here at x sub n minus 1, so the second to last spot, because again, that's our left-hand side of that last interval. So up here when we have 6 intervals, we're going to stop at x sub 5. And our right-hand approximation is really, really similar, except instead of using the left-hand endpoints, like we've got here in our picture for left-hand endpoints, we're going to use the right-hand endpoints of our interval. So it's really just a matter of which one of the endpoints you want to use to find your sum. Here with this particular left-hand sum, we get sort of an underestimate. Here with our right-hand approximation, we get a bit of an overestimate. But as we make those rectangles smaller, our approximations get a little better. And it isn't always true that the left hands are underestimates and the right hands are overestimates. That's something you'll look at in the homework. Kind of depends on whether your function's increasing or decreasing. But a right-hand sum, so we make that notation that we're doing a right-hand sum with an r with a subscript of n. So again, that n is the number of rectangles that we have. And here we start with a sub 1. So we don't use this first left-hand endpoint at all in our calculations because we're using just the right-hand endpoints. Just like on our left hand, we never use the last one because it's a right-hand endpoint and we're only using the left hands to get our heights. So it starts at x sub 1, and it goes to x sub n. And we can, again, sort of shorten up that notation as a summation from I equals 1 to n of f of x sub I times delta x. So again, that height, when we're plugging in that left-hand endpoint here, we're getting the height of that endpoint, or the height of that rectangle, excuse me. That's f of x sub 0. That y value, that point right there, That's x sub 0, f of x sub 0. So that y value tells us how tall that rectangle is, and its width is delta x. And all of these widths, are, in fact, are delta x. They're all the same. And so we're just finding the different heights, whether we're doing the left-hand endpoint to find our height or the right-hand endpoint to find our height. So let's take a look at an example with this. So we're going to find a left and a right endpoint sum for a quadratic that they're giving us here on the interval 0 to 3 with 6 subintervals. So they don't give us a graph, but that's okay. And what I do when I'm not given a graph is I actually make a little number line because this helps me kind of visualize what I'm doing. So I'm looking at from x being 0 to x being 3. We do need to figure out delta x in this case. Delta x is always b minus a divided by n. A is the beginning of our interval, b is the end of our interval, and n is the number of little pieces that we want to make. So we get 3 minus 0 over 6, so that's a half. So this is going to tell us that we're going to make a break at a half. So we go a half from 0, we get to 1/2. We go another half, we get to 1. Then we get to 1.5. And yes, I'm using, oh, I didn't space them out really nicely. I'm using fractions there, but we can use decimals when we're actually plugging them into our function. So here are our different intervals. So here's an interval. I'll just highlight a couple of these. Here's an interval. And we have 6 intervals. Maybe we'll go like every other one. There we go. And for our left sum, so we're going to do a left sum with 6 intervals. We're going to start with, that first purple interval. The left-hand side is f of 0, so we're going to find f of 0, then times our delta x, which is 1/2. And then we're going to go and take the, this green interval now, go to the left-hand side to find the height of our rectangle times our delta x. And we're going to keep doing this until we get to our last interval, 1.5 times a half plus 2 times a half plus 2.5 times a half. So again, we can kind of underline which is, sort of the green intervals, which are the purple intervals. And we're just doing the left-hand side. So we don't use 3 because that's on the right-hand side of that last interval, and we're using a left-hand sum. So now to actually figure out what this sum is, we need to plug in 0, 0.5, 1, 1.5, 2, 2.5 into our function. So we're literally going to go 2 minus, or we're going to like literally plug 0 into that. Sorry, I was kind of like reading it and thinking about it. So 0 squared minus 2 times 0 plus 1. 0.5 squared minus 2 times 0.5 plus 1. I can show you in class how we can use Desmos to help us out with this. So I'm going to write that 1/2 out in front, kind of factor it out like we do with summation notation. When we plug in 1 or 0, we get 1. When we plug in a half, we get 0.25. When we plug in 1, we get 0. When we plug in 1.5, we get 0.25. When we plug in 2, we get 1. And when we plug in 2.5, we get 2.25. So we add all those up, multiply it by 1/2, 4.75 is what we get from adding them all up, and we get 2.375. So that's our left-hand approximation to the area under that curve. The right-hand approximation, now we're going to use the right-hand side of each of our intervals. So how this is really going to change, all that's really going to change is that we're not going to start at 0 now. We're going to start at 1/2. So we're going to start at 1/2 times 1, and that's going to give us the height of that first purple interval. And then we're going to have f of 1 times a half, f of 1.5 times a half, f of 2 times 1.5, plus f of 2.5 times 1.5. And our last interval, we use again that right-hand side. So here's our first purple interval. There's our purple intervals. There's our green intervals. And again, it's just a matter of plugging all of these numbers in. We already did a whole bunch of them. And so I'm literally just copying from up above because We plugged in almost all of these except for f of 3, and f of 3 we get 4. So we get 1/2 times 7.75, and that is 3.875.